Hi, this is Nagarajan here. A warm welcome to the second technical webinar organized by TIECONN. So, good morning, good afternoon, or good evening, depending on where you are joining us from. So, it's great to see so many familiar faces from our last webinar, and we are equally excited to welcome many new participants today. So, today's topic is an important one, as you know, egress and smoke management for fire life safety, something that every MEP engineer must be aware of in order to design a safe and code compliant buildings. So as part of our mission, I mean the TIECONN mission to share knowledge and inspire innovation in the MEP field, we have planned to host one technical webinar every week. So starting next month, we will also announcing a series of additional webinars and technical events. So stay tuned for more engaging sections. So now, without further delay, I would like to hand over the mic to our TIECONN youth chair, Mr. Nabil, who will continue the introduction from here. Yeah, Nabil, you can start.
Good evening, everyone. We are host TIECONN, and we are excited to have you all join us for the important session on egress and smoke management for the fire life safety. So I will be guiding you to the first part of the session. Before we dive in, let me quickly walk you through our agendas. We will start with a short introduction to TIECONN, followed by our vision. Then I will introduce our leadership, followed by a brief on today's speaker, and after that, we will hand it over to our expert for the main session. So this is it about TIECONN. TIECONN, which stands for Technical Innovation and Engineering Consortium, consortium is a global platform created by engineers for engineers. So we bring the professionals, students, and the experts from the world to share knowledge, host training sessions, and build a stronger, smarter, and technical community. Our vision and collaborative engineering platform where innovation, knowledge, and community comes together to shape the future of and the technical industries. So this is our mission statement. So primarily our mission focus on connecting passionate engineers through mentorship, training, and technical. Also, we aim to empower young professionals like me, promote sustainable design, and celebrate technical excellence across the globe. So let's move on to the team introduction. Now I like to introduce the passionate team behind the TIECONN. Our committee members, Mr. Nagarajan, Mr. Victor, Mr. Raghav, are the vital role for the TIECONN. So these are our executive leaderships. So these are our country chairpersons. They are all from Middle East mostly, Qatar, KSA, Pakistan, UAE, Bahrain. And this is our technical advisory and awards chair. And FM sectors. So this is our youth and student division. I'm responsible. So these are our event organizers. They do excellent planning and execution technical winners engagements. I can say they are the pillars of the TIECONN. This is our media and communication team. They are effectively engaging communication across social media. They do marketing campaigns and internal network. So meet our session leader today is going to, now let me introduce our distinguished speaker for the evening, Mr. Hemant Khadse, CEO of East Corporation Group. He have over 30 years of experience in life safety, and he is a leader in his field and has conducted more than hundreds of audits for top line across India and SAARC countries. To our today's session will be focused on egress and smoke management. So the key concept is all about protecting lives during fire. You are an MEP engineer or safety officer or designer, this webinar will offer valuable insight and practical knowledge for you. So with that, I like to hand it over to Mr. to begin the. Let's move into
Thank
webinar.
you. Thank you, Nabil, for a quick introduction.
Thank you very much.
You can off the screen. I will share my screen. Yeah. You can stop sharing. Yeah. Thank you. So welcome everyone here on behalf of TIECONN. Very, very nice name given to your association. Good evening and salam alaikum to all the people. In fact, with this community, I got my old memories alive when I was in Bahrain during my startup career in 98 to 2001. I had enjoyed working in the Middle East region. So now when I interact with all the Middle East engineers, my memories is alive. So thank you, Nagarajan, for giving me the opportunity today for interacting with your associations members. I believe there are 38 members here in this group, and it's growing. Wish you all the best. I think knowledge is all about sharing, and that's how you gain it. So when you start collaborating, breaking your boundaries, and keep that mission alive of learning, I think the innovations begins there. So we are all into the fire and life safety domain, and I think it's important that we should keep that light up all the time of learning and learning. So this is your webinar too. I'm sure you will have every week some new opportunities to gain knowledge, and I would be happy to share as and when the opportunity comes in and our calendar works out it. So today the topic that we have chosen is to talk about on two important aspects of life safety, which usually is not been so focused well. Smoke management and egress. How this passive part of your fire measures is going to impact the life safety, and how the engineering is going to make difference in the life safety component of any building is a topic of today. So I will just try to cover the basic principle and fundamental of these two key aspects. How the smoke management is been discussed and deliberated in terms of codes and standards, how it has been applicable, how egress has been implemented on various projects, and how it is going to impact life safety directly and in specifically relation to the smoke management. At the end, we will have also some small quiz for you to make it more interesting, and I think TIECONN is going to award some of the winners. So I have volunteered here to award on-spot winners at the end of this webinar. In case you have any questions, you can put it on the chat. We can probably address it if the time permits. Essentially, when the smoke as a topic is in talk, we all know that when we read a lot of accidents as in every country, I'm sure the incidences are less in your region, but in other parts of country, like in India and in SAARC countries, the accidents are very, very common because of various reasons. But the more prominent reason that is been focused is the smoke and egress. We all know that when the case studies happen, when the fire incident or investigation happen, the common cause doesn't come out very clearly or evidently, but we all know that smoke is the killing giant. And it may not be necessarily the fire could be the cause, but the smoke, which is going to be the major cause of a concern or a death, even for that matter, when it comes to your life safety. So smoke, technically, we all know that fundamentally it is a mixture of liquid, solid, and gas. And the major chemical composition that is present in the smoke is carbon monoxide. That's the most killing chemical that exists in the smoke, which is making that as an hazard. So when you deal with smoke management, essentially you deal with these two chemical agents, which is carbon monoxide and carbon dioxide. But apart from that, it's of course HCl and HCN also as a combination of it. And why it is becoming more hazardous? Because of its all characteristics that is dangerous to your human life. The worst scenario could be the human death, but also there could be many other physical impurities that may damage and hazardous to life safety in terms of impaired visibility, coughing, irritation. So there are many parameters that are attached where it becomes the matter of a concern, and that's the reason codes and standards globally have addressed this smoke management as a very critical component of it. But the reason being that is not been well dealt, because unfortunately the ownership doesn't come to specific domain. When the MEPF consultant actually designs it, the HVAC, the engineer is actually responsible for more on comfort, but it's very seldom that he addresses the smoke scenarios unless been asked and code insists for. Especially as a life safety engineer, why it is important that we need to coordinatively look at this aspect, because it is not just one man's territory or domain that will take as ownership. It is a coordinated effort. Your fire alarm, your smoke management, your sprinkler systems, your egress, all put together becomes the one engineered solution or a systems, and that makes your building safe. When architect actually designs, he also have to look at how the smoke propagation happens inside the building, how many openings, how that openings results into a passage of a smoke vertically or horizontally. When a HVAC guy designs it, the ducting systems that has been designed, how it is going to be taking care of hot smoke, how the stairwell is communicating to your connecting corridors and the elevators. So smoke will always find a way to pass through the building horizontally or vertically, and that's the reason it becomes very evident that it's a coordinated effort that architect and engineer have to work together in tandem on the drawing board during concept design stage and see that the system is well established and complied both. IBC or NFPA, or even for that matter your local codes in UAE and India, are also very, very focused in terms of smoke management, and it becomes a priority systems. When you look at a clear clause in IBC, it is very clearly spelled out that smoke control must be given a highest priority, followed by fire alarm, and then BMS. So when you design a cause and effect matrix, especially the ICT people who are here in this room, they are instrumental in designing the cause and effect matrix. So that becomes the base for you to commission and operate your systems, all coordinated systems. NFPA 4 and 5 also addresses, NFPA 25 also addresses, especially the NFPA 72, which is a fire alarm code, also addresses how your coordinated systems, integrated fire alarm systems is talking to all auxiliary systems when you design it, when you commission it. So smoke control has a very, very direct impact on evacuation. Why? Because when you activate the smoke management or a smoke control systems, it essentially helping for people to evacuate the building safely and speedily. Because all we know that smoke is going to be hazardous for a human life, and that's the job. The critical job of a smoke control system is to minimize the smoke damage. And of course, not only for egress point of view, but ingress point of view, how your firefighters are going to come to the building, and when they come into the building for rescue and firefighting operation, how they are going to get the access to the building, and they have a smoke-free egress path for them to rescue and help people and occupant in case of fire emergency. So it has got a both impact. So it is not necessary that we design a system that it is only helping people to evacuate, but also for the duration where firefighting operation also becomes safe and quick, so that it becomes a quick operation when it comes to first responders. So smoke control management is a overall coordinated systems, as I mentioned to you. It is a most critical part of a designing, and also for a risk management, it is important that they also look at this aspect, whether it's an insurance body or AHJ body. It is important that the smoke management is evaluated very, very clearly. Nowadays, the building construction materials are really getting in different forms and innovations. There are a lot of construction materials that are being used, which are not necessarily flame retardant or fire retardant. So how your building interior finishes are getting inside the building, could be hotel, hospital, office, residence. So two parameters are to be evaluated when it comes to building material, which we all know that it is addressed in codes and standard, which is smoke development index and flame spread index. So there are classification given in the codes and standard ABC or 1, 2, 3, how the rating have been given to that particular material. It could be carpet, curtains, material, liniens in the hotel especially, or any of the occupancy. So are these materials going to comply the properties of not generating smoke, or also having flame resistive properties? And this is what the part of your passive fire measures. Architect usually supposed to look after it, but somebody has to evaluate, and that's it's a job of a life safety engineers to look at whether it is ensured or not. So things have become very, very changed in last 20 years specifically, where smoke management is very, very becoming evident when it comes to building design. There is also another aspect which impacts heavily on life safety, is a compartmentation. Now that compartmentation essentially is nothing but a principle where we are trying to confine the smoke to a limited space. So it becomes a safe zone for adjoining occupants to either evacuate or defend in place. So when it comes to basement under the building or any large occupancies where compartmentation becomes a very prevention strategy, and it has been implemented at even codes and application level. There are specific areas have been given and regulated. There are various means of achieving compartmentation. It could be by using fire curtains or water curtain, the fire rated walls, fire doors. So compartmentation essentially becomes the important part of your life safety design at the construction level, where you are ensuring the life safety and even the smoke management per se, because it is ultimately protecting your egress path so that your evacuation becomes very safe. So how these barriers have been protected as a part of a compartmentation could be horizontal, vertical. So again, there are unprotected openings which are exist in the building through pipe, cable, or duct have to be sealed with fire sealed materials. There are glass facades opening. There are various other unprotected openings through your industrial operations or utilities areas. So those have to be sealed so that your openings doesn't become a passage to the smoke movement. So when it comes to smoke management going forward, let's look at the philosophies or principles that are available for engineers to implement. So the first parameter that I mentioned about the compartmentation, it is also called a containment. It's a passive way that you can create the fire barriers within the areas so that in case smoke happens, it remains in that particular zone. It doesn't go or spread to the next horizontally or vertically. There is a mechanical way to protect by creating the pressurization. We'll talk about it in a minute. There is also a system called purging, where you're inducing the airflow into the environment and you're creating kind of a positive pressure, and also it becomes a part of a smoke management systems. There is also negative pressurization, which is also called venting or exhausting, where you are mechanically taking out the smoke into that from that particular fire zone, and that's how you are preventing fire or smoke not to go to the other floors or other areas. But when you look at this smoke management and designing or getting involved into the designing, you have to see that as a whole systems, because you expect the area that you are designing, and especially a mechanical powered smoke management, you are also expecting the existence of sprinkler systems, or in an area where you have a gas systems. So how it is going to impact the operation of your mechanical ventilation systems, and that's reason it becomes an engineer solution, and various codes have been addressed in different ways. I think this screen will be okay. Nagesh, this screen is not obstructing, right? It's clear
No,
screen
no
and
issue.
my
It's
audio.
clear.
Okay, thank
It's
you.
clear.
So going forward, containment is the most common strategy been applied in various high-rise buildings, especially. It could be anything commercial, residential, hotel, where you are trying to control the fire and smoke to that specific area structurally. So it is important that we validate that along with the architects with the fire rating that is expected or required given by the codes and standard. It could be fire walls, fire doors, dampers, and it covers both horizontally and vertical smoke propagation. These smoke zones, when you try to create in that particular environment with the fire dampers, again, it is part of a containment strategy. So when you design the systems, you have to also work with HVAC engineers to create those fire and smoke barriers. How that integration is going to be reflected in your cause and effect diagram, how your fire alarm system is going to behave in fire emergencies. What is the job of your smoke vent? What is the job of your fire dampers when it is going to activate? What's the rating of the damper? All these things have to be engineered. So when you look at various illustrations of buildings, you have all options. I mean, code doesn't specifically gives you an answer how your systems could be applicable for your particular project. Building code is unfortunately not so explicitly elaborates how the smoke management is to be designed. It's only the building code gives you what. That means what kind of a system that you can probably think of or can help you to build your life safety and smoke management system is there. But how that smoke management systems is going to be, we'll have to look at it. I will address the questions if you want at the end. I think there is one hand raised. Unless until it's a burning question, I don't mind taking it. So is that okay if I take the questions at the end?
Yes, we can take at the end. Yes, better. Yeah.
Thank
We
you.
can summarize all the questions and we can
Yes,
see there.
absolutely. Yeah, because then my flow and the question flow also can be better way. So when you design these smoke zones, you have to use the engineered way and see that how your mechanical ventilation is going to be engineered so that your area becomes smoke separated zones and they are coordinated. When you look at all the applications, as I mentioned to you, you have all the flexibility and applications given in the standard. By means you can define your strategy in your report or in your design basis at the design level, so that the integrated systems can be established. As I mentioned to you, your sprinkler system is going to exist and operate also in fire, so as your smoke extraction system, so as your pressurization systems. Especially when you talk about pressurization, it is again a very, very complex systems to design and engineer. In fact, I would say going one step beyond, it is also very difficult for you to install and maintain. At many instances, we see the pressurization has been implemented with a little over design way or under design way. The example of over designing is that when you implement by looking at the codes and standard, pressurization is required on a specific floor, and that too, just to give an example, for a hotel building, high-rise building, the lobby is pressurized, the staircase is pressurized, the lift is pressurized. Now, when you have that scenario that you have a all floor been designed with pressurization as an option, it's the best strategy. But when that strategy is evaluated only from the eyes of pressurization, it might be a best strategy. But imagine a scenario that a fire alarm triggering the pressurization on that particular fire zone floor. Your pressurization is going to be acting simultaneously. How it is going to impact on your door so that it doesn't become the issue for people to evacuate. Or it could be the issue that you have a lot of simultaneous evacuation happening from multiple floors, and that door openings might dilute the airflow, and that may affect, and it could not lead to build that differential pressure that has been set or required from the code perspective. So when you design a pressurizing systems, it has to be seen that how it is going to impact and intercommunicate to the other systems available. It could be the pressurizing systems from the other side. It could be the activation of sprinkler system, which will again reduce the smoke propagation. It could be the door force, which is going to impact. It could be the number of openings for evacuation, ingress and egress both. Also another scenario that when you build a cause and effect diagram and a pressurization systems, if it is going to be the false alarm, how it is going to lead to the pressurization. Your detection system is not so reliable, or maybe it will give you a delayed detection. Instead of giving the fire zone floor detection first, it is going to give you detection to the upper floor first, and which will lead to the activation of that particular floor as pressurization. It might lead to different, because you will have different strategies to activate. So I wanted to impress upon the factor here is that when you engineer the systems, you'll have to also work very carefully, working with all engineers, HVAC, life safety, and the architect, and build that logic how it is going to be more prudent, practical, and creating that life safety effectively. Fundamentally, why the pressurization is going to be more effective, because we all know principally the smoke is always going to transfer from high pressure to low pressure. It is not the other way around. So when you build that differential pressure, supposingly you are pressurizing the staircase is built with a high pressure with the jet fans or extraction fans, mechanical fans. The connected lobby will have a low pressure, and ensuring the lobby smoke will not enter into the staircase, because we wanted to protect the staircase first, being an exit route. Same as the case when you pressurize the lift well, you are also going to create the differential pressure inside the well, so that the well will not have an ingress of smoke or smoke infiltration into the well, so that the lift well also will not transfer the smoke into the lobbies, which is making the egress difficult for human safety. So fundamentally, you are using that differential pressure technique. But what is that Pascal? So code has always regulated minimum and maximum pressure. Minimum is 12.5 Pascal and maximum is 45 Pascal. But again, depends on the codes and regulation. You have minimum and maximum Pascal, which is going to be creating that differential pressure for various zones. It could be staircase, It could be lift well, it could be lobby. And again, you have various options to do that pressurization. Now, when you do that pressurization technique, there are also codes are given various options. Again, that is an engineer responsibility to design it effectively, that how my fire zone is getting activated, and if suppose that fire zone is activated with an exhaust, then my adjoining floors, how it is going to behave at the same time. Like in specifically, if you look at this particular slide, you will see that you can create that logic, like if there is a fire floor which is going to create the exhaust on, the floor above and below can be pressurized so that the smoke doesn't transfer to the adjoining floors. If suppose fire floor has got a lobby which is also pressurized, you can also do that by creating the pressurization active on high mode, at the same time vent closed. So you have various combinations, and again, there is no cast and concrete rule that can be addressed by any codes or standard that this is the most applicable strategy for your facility. It is the purely engineer's purview how you are going to implement this particular logic and built into the system so that it becomes your own engineered system. So when you also design the pressurization, there are essentially non-compensated or compensated ways to do that. That means when you expect some of the door openings or the evacuation process that is expected in that particular building, which will allow the fresh air to get diluted, the pressurization, you have to include that in your calculations and then design your CFM capacity of your fans. At times, maybe the staircase is only pressurized, but lobby is not. The lobby has got a lot of windows which are in the form of louvers. You expect some of the openings which will induce the fresh air to come in through the openings which are available. The systems will have different calculations, and code has given how these systems can be defined, and your staircase pressurization fans can be engineered. So that's how it has the non-compensated or compensated engineered systems available, and you can have even single injection or multiple injections fans, again based on the occupancy that you have, based on the type of the building or height of the building that you may have, and you can actually define your pressurization systems so that the staircase, which is the most protected zone, becomes the smoke-free zone for evacuation or evacuating people. Elevator lift well is the most complex system to design because you expect the piston effect, and especially when it comes to fire lift, you expect that fire lift to be on for firefighters people to move in and out. At the same time, your pressurization system is activated, you will have a reverse effect. At the same time, when you have connected lobby as also pressurized, you will also see that some of the openings which will also be an hindrance for your pressurization. So the expected differential pressure that you want to build into the elevator lift well shaft is not possible when you don't design it right. So you'll have to have that all consideration given while doing the calculations, how my system is going to behave in real fire emergencies, expecting the fire lift to move in and out, expecting the lobbies to be available for egress, people to move in and out to the staircases, or first responders. Doors and dampers are also as part of your smoke management. Very, very critical component. It's again a part of a passive fire strategy, but essentially it is a design that has to be taken into consideration to limit your passage, smoke passage into the building horizontally or vertically. So when you design a systems using the fire dampers, you'll have to see what's the logic that you are going to be building into your project, how your supply and return ducts are going to behave, how your supply becomes a return air duct, and how your exhaust is going to be activated, when it is going to be activated, how your adjoining floors are going to be behaving when it is going to be a exhaust mode for that particular fire zone. Are you building more than one floor adjoining as the pressurized smoke zone, or you have only the exhaust opening on that fire zone? So this is again part of your engineering, how your dampers are going to be acting as the barrier to restrict your smoke from going horizontally or vertically. Vents and dampers are interchangeably used, but vents basically intended to open the smoke to escape the building, that is negative, and dampers are basically to close the airflow or the smoke flow. So that's how it is part of your design. So this is typically the integrated systems, how it is been designed in coordination with building engineers, and especially when you have elevator, staircase, and the connected lobby also has pressurization, how it is going to be integrated, how your smoke control systems can act as one systems to activate multiple smoke zones, taking the input from fire alarm, how we are going to use the cross zone so that you can reduce the activation of smoke management. Your dampers, where are going to be used, whether you can eliminate the lift well pressurization and have only the lobby as pressurization when your staircase is already pressurized. So these are various techniques that engineers need to apply and develop your own fire life safety strategy using the compartmentation technique. In fact, personally, I am always in the favor of not to pressurize the lift well when your lobby and staircase is pressurized, and that becomes your fire shaft or protected shaft for first responders. But when you have integration possible, it is important that your differential pressure is maintained. If you don't maintain your differential pressure, what has been regulated, then the purpose is defeated. So this is again the example that I want to illustrate here, just to explain the principle of smoke management, and especially a high-rise building, how you going to create your smoke zone activated with exhaust and adjoining floors, which is above and below, creating the positive pressurization so that the smoke doesn't transfer to the upper lobbies, upper floors. So this is a job of a life safety engineer to ensure that the system is reflected as part of your cause and effect diagram. When corridor is pressurized, again, it is dual responsibility for you to look at your force on the door doesn't exceed more than 110 newtons, because that's again regulated by codes and standard. At times when you have only single injection pressure in systems, there are high chances that the location where your fan is located, either in the ground floor, which is also final exit discharge, you will have a lot of dilution of airflow. At the same time, if suppose you are on the top floor as the supply fan for a pressurization, you will also expect the door opening for egress. So maybe the pressure is less where the door opening is high, or door opening is been used as part of egress, and the other floor will have high pressure. So you have to really see that whether differential pressurization technique or systems that been used, so that you will not have imbalanced pressurization or a force which is there on the door, which is higher than what is expected for human person to use it. So pressure differential systems are more popular, where you will be able to mitigate the risk and see that it is protected uniformly. That's how the systems are now well engineered when it is coordinated with other building engineers. When you use exhaust systems, how your makeup air is expected with the door openings or mechanically, so that you have effective pressurization or negative pressurization systems into the building, because you have to not only just take the negative pressure, you also have to have a makeup air to complement that exhaust system, so that it becomes the diving effect. So level of pressurization again addresses by NFPA 92 very well. You can probably take the basis of codes. IBC also has addressed multiple chapters where you can get the basis developed. ASHRAE also has got a very good manual which is addressing the smoke management techniques and the principle. That's how your systems are going to be designed, as I mentioned to you. But the whole point that I want to elaborate here is that when you look at all the applications that are there in your codes and standard, you'll have to see that how it is going to be more effective for that particular project, at the same time practical. At times I have seen in many places where the pressure system is installed, but it has never been maintained well, it has never been checked periodically, and you don't even know the operator whether that staircase pressurization fan, what is the differential pressure right now it exists after 5 years. So importantly, when the engineer like you are responsible for designing the systems, make sure that it is also documented well in the form of as-built layouts or in the manual, handed over to the operation team with the training, with the AMC plan, so that the systems at the end is effectively used in real emergencies case. Maybe in next 10 years, it need not to be used at any point in time in fire emergency, that's fine. But if at all it is required, how does it need to respond? So engineer responsibility is not to only design, but also to document it. Of course, this is just an example that I want to share with you, that in India, the 9BC have addressed in the form of table 6, how the pressurization or in the combination of natural cross ventilated options can protect your staircase or lift lobby connected. So you have combination of both. It's not necessary that only the mechanical ventilation is the solution available by codes and standard. It is also a natural ventilation, either through the openings or maybe by the cross ventilations options available. Basement again is a very critical because of the gases available in the form of car parking and other utilities. Very important to have ventilation systems for especially car parking and the basements areas because of the hazards which are available. CFD is very important tool nowadays. I'm sure in your country it's a very common practice, but it's going to be the main ingredient of your design to validate your ventilation systems, whether it is effective. So there is a simulation that can be done to validate your ventilation systems, the CFM, the airflow, so that the system that you have installed or you want to install is effective and also has got a performance validation using the tool that is available. So CFD is very common nowadays, in especially when you have basement, especially as an area, as a high-rise building or a mixed-use projects, and it does help the building professionals to define your basis of the smoke management as an integrated with your HVAC or fire alarm, and it is very important tool as part of your performance-based design also. So just to summarize the pressurization before we get into the egress, is that it's a very well established method. It helps you to make your occupants egress more safe and speedy, at the same time also for our first responders to come in and help you to rescue or fight the fire. So you have, as I mentioned to you, multiple options. You can have it at single injection or multiple injection. Again, code doesn't give you specific answer. It is the building engineer to define what's my strategy. So strategy could be combination of prevention, as I mentioned, to the compartmentation, or the mechanical way that you can apply the principle and define your extinguishing strategy. It is important that you have to work with an architect to look at the fire barriers, the openings that are available, and again, based on the occupancy, you can decide what's my compartmentation requirement and how it can be achieved as a part of passive fire protection strategy. So apart from the compartmentation, it is also important that your fire doors, walls, interior finishes, dampers, fire stops are also well captured and defined very clearly. But overall, when you design the systems, you have to always look at the fundamental which is there in the codes and standard, that whatever system that you are designing is always based on single fire incident at any one point in time. It doesn't have to be necessarily that you have two scenarios in one time. It is always at single scenario as the base of your fire life safety strategy. It also doesn't address the arson or any kind of a deliberate attempt. It is always containment as a first strategy. Means of egress is always minimum 2, because if in case one is compromised with your smoke, it has always a provision to go for the second one. And then travel distance becomes the important criteria. So when you look at the egress, there are three components from a place where you are on any floor. The first is that you are trying to reach to the nearby exit, and that's the reason it's called exit access. That's the first means of escape or means of egress. When you try to identify the fire exit, which is a staircase, which is protected, which is separated, segregated, then you try to use that as an exit and go to the final exit discharge as the last means of escape. And that's how you complete the process of egress. Very importantly, that people are aware about the criterias that are stipulated in the codes and standard. So every codes and standard has got different travel distances based on the occupancy that are there. So travel distance essentially is the pathway, which is combination of your common path to reach to the fire exit. So code always regulates your travel distance, code always regulates your common path and dead end both. So dead end is very important, that we'll have to see that it doesn't exist in your project. It's a path where you are actually using a distance, but thinking that is an exit is not an exit. So you have to turn back and then go to the appropriate fire exit. So that's a way to look at your common path and dead end. So every occupancy has got very clearly defined what's my common path, what's my dead end, and accordingly you'll have to see it. But if at all, if it is going to exceed more than regulated or prescriptive way, there is a performance-based standard which can meet your life safety objectives. And apart from the codes and standard, it is also important that you have to look at all the aspects which are not there in the code, but can influence your egress, which is building characteristics, occupant characteristics. That means a male or female, or physically impaired people, or children, or even the ladies which are having a lot of physical disability. What's my characteristics of fire? What's the knowledge level? Frequent people, first time people, visitors, contractors have different behavior, condition of the time, activities in the building, whether it's a event, fair, or it's just a midnight sleeping time. What's my physical impairity options available in the egress? What's my architecture? Heritage building, a new building, modern building. What's the personality? VIP or kind of a contractor employees? What are the fire safety measures available? Sprinkler system, non-sprinkler systems, fire alarm, non-fire alarm. So these are various factors that also influence the egress, and it is not addressed explicitly by any of the codes and standard. But as an engineer, you have to also look at when you design the systems. It could be fire alarm as the life safety systems, or connected your auxiliary systems. So always prescriptive and performance is options available. It is not necessary that you have to restrict only to prescriptive unless until it has been very enforced. But if there are site challenges because of the operation, because of the availability of existing structure, you can always look at the performance-based standard to meet your life safety objectives. So performance-based standard has got a very clear mandate. NFPA 101 has addressed. SFP manual also has addressed how this can be achieved using the simulations techniques, where you can define your available safe egress time. You can define what's my required safe egress time. So it's a very engineered way how you can define your RSET is lower than RSET. That's a objective of life safety, so that you are ensuring the egress is safe for any person of any impurity, of any gender in that particular building. There is no cast and concrete rule to have specifically minimum RSET. NFPA 1 has got a given general statement as not more than 8 minutes, but depends on the building. If suppose the building is like World Trade Tower or Burj Khalifa, definitely you cannot expect the total evacuation time can be single digit. It has to be multiple digit, and at the same time, staircase may not be the choice of a egress. It could be elevators as well, fire evacuation elevators. So depends on what the building occupancy is there. You can actually define the asset and RSET. So CFD egress simulation could be the combination where you can ensuring your tenability and visibility. So tenability is something that expected from the best practice as 1.8 meter to 2.5 meter based on the height of the building or occupancy type. The visibility, again, it could be between 4 meter to 20 meter. So depends on again the building that you expect that visibility is to be ensured. Visibility need not as a hazard, but it can become a hazard or it can delay your evacuation. So as tenability. Tenability also might delay, but if suppose the smoke is going to be inhaled and that too in a very large proportion, it is definitely going to hinder or become an hazard for human life safety. So this is what all I had. Sorry, I have taken more than probably just 1 hour, but I think all I wanted to influence upon is to give you the overall principle, fundamental, so that as a life safety engineer, when you work with an architect, when you work with a developer, when you work with AHJs, you can understand their language. So smoke control management is definitely a becoming bigger concern, and especially when the code has not specially addressed how, it has addressed only what. So fire alarm and building management systems as a coordinated systems is very, very challenging because of the integration involvement, because of various systems behavior at the same time in fire emergencies, how it has to be designed and implemented. The mechanical or combination of natural ventilation is again a big challenge where you can have the combination of both to impact your life safety or egress. The construction of the today's modern world is again changing the entire ecosystems and building design. So it becomes evident that you have to ensure that the smoke management is in place for a egress point of view or from life safety point of view. And we all know that smoke always the killing giant. It's not necessarily the fire. And we have a lot of evidences worldwide where it becomes prerogative that we should look at the smoke management as an engineered solution, and it has to be implemented at the design stage. So that's all from me. I'll be more than happy to take questions. In the meantime, we can probably use this time to take refresh of whatever you have learned as a game, not as a competition. But you can just scan this using your barcode, using your mobile phone. I will start the timer. You will get a 1 minute, and then probably there are about 10 questions which are very, very easy to answer. And we can probably announce the winners. And in the meantime, I'll take this time to read your questions. So we are all ready. We can start the timer now. Very good. Thank you so much. I have my volunteer Anupam who will probably announce the winners in a minute, so we can get live results. So thank you so much for the opportunity. Let me open the chat in case anybody has any questions. Okay, by that time Anupam will unmute, I will read the first question here.
Yeah, I'm just downloading the responses. We'll
Yes.
be announcing the winners.
Yes. Okay, there was a question from Arifullah. Only fire floor will have a makeup and extract. Yes, usually that's the best strategy, that on the fire floor you open the vent or use the extraction systems, and adjoining floor you create the positive pressure. But when you activate the extraction, definitely you have to see that the makeup air is available for that particular fire floor, either in naturally or mechanically. What is the role of sprinkler and drencher in smoke control? Definitely it has a greater role, and that's the reason when you specially design the smoke management system, CFD becomes more important tool, because that tool can actually take care of the input as sprinkler, and it impacts on the heat HRR, and it is important that you have to take that into consideration for activation of your smoke management. Smoke management were not adequately taught in fire training school. Yeah, that's the reason I mentioned that code doesn't address it and explicitly, and that becomes a gray area. How do you understand dynamism of smoke management tool? That's in this seminars and learning opportunity can make you expert when you handle hands-on projects. How CFD played its role in smoke management? As I mentioned to you, CFD has a greater role in validation of your ventilation systems, that to CFM, the airflow, the directions. Um, so it has got a two application. One, to validate the HVAC systems, so that you ensuring that SAPH is intended. At the same time, from the life safety perspective, when you look at that, is a combination of asset and RSET, you can ensure CFD to see that what is my available safe egress time, so that you can evaluate in relation to the RSET that is required safe egress time. So definitely CFD has a very important role to play in engineering. Which program that gives you accurate result, we can use it to calculate exhaust and makeup air. So actually has got given very good calculations tool that's available on their website, so that can be used to calculate the ventilation system as such. So Anupam, are you ready with the announcement?
Yeah, I am ready. So I'm just sharing my screen. Can everyone see the screen?
Yeah.
Okay, so this is the median score that we have got 5, and the winners are in this order. So we have Shalikul Huda, who has won the quiz with rank 1, then Nabil, then Ashwak, then Deva Dethan S, and Anwar.
Okay, thank you so much, Anupam, for the help. I think Nagarajan can probably take the
Yeah, we
screenshot
can.
and
Yes, we will approach. Yeah,
take
we will
this.
approach them.
Yes,
No issue.
yes.
Yeah.
Thank you, Anupam. You can share
Yeah,
this.
thank you.
Okay. So, thank you so much. Over to you, organizers, in case anybody wants to have as a closing remarks.
Yes, sir. A heartfelt thank you to Mr. Hemant for being the speaker of our second TIECONN webinar. Your session was nothing short of exceptional, a long, detailed, and highly insightful presentation that kept our audience engaged throughoutly. So, the depth of your knowledge share reflect your experience and dedication to empowering the MEP engineering community. On behalf of entire TIECONN team and our growing network of professionals, we truly appreciate your valuable time and effort making this webinar successful. Looking for more collaboration in your future. And once again, thank you so much for your, the thoughtful presentation is really amazing actually. The sliding wise and everything is detailed. You explained. Thank you so much, sir.
Thank you. Thank you, everyone. Take care and
Yeah,
good night.
thank you everyone
Thank you.
for joining today, and also thank you, Mr. Hemant, for a very detailed section. And the winner, I hope you are in our WhatsApp group. Are you there in the winner? Are you in our WhatsApp group? Okay, no issue. Otherwise, we can also contact him for the further communication. So, thank you all. Thank you, Mr. Hemant, once again for such a interesting and insightful webinar today. Thank you.
Thank you so much. Look forward to
Thank you
connecting.
Thank you so much for everyone.
Thank you.
Thank you. Yeah.